Hey everyone, ready for some mental math magic?
Oh, I like that. Math magic.
Well, we're diving deep into Vedic math today. It's this system of calculation techniques that comes from ancient Indian scriptures.
Pretty cool, right?
You bet. You send in some amazing material on it. It covers a ton of stuff like completing the whole, doubling and halving, and even things like the 10-point circle
Ah, yes. The 10-point circle.
and digit sums.
Yeah,
I'm super curious to see how it all works.
me too. I think we'll uncover some pretty neat tricks. Well, not just tricks, really.
More like shortcuts.
Yeah. It's all about understanding how numbers relate to each other, on a deeper level.
Okay, I got a bit. When I first saw a 10-point circle, I thought, ooh, pretty. But how does a circle help with math?
Well, think of it like a visual map of how numbers work with the number 10. You put the numbers around the circle like a clock face
Right.
in pairs that add up to 10.
So 1 and 9, 2 and 8.
Exactly. 3 and 7, 4 and 6, and 5 and 5. This helps you see how to make groups of 10, which is like the basis for a lot of Vedic math techniques.
That makes sense. So it's all about making tens.
Yeah. It's a fundamental principle.
So like if I was adding, let's say, 24 and 26,
Okay.
I could use the 10-point circle to see that the 4 and 6 make 10. And then I've got 20 and 20, which is 40, plus that extra 10. Boom, 50.
You got it. You intuitively saw how to get to that nice round number, a multiple of 10.
So instead of memorizing addition facts, it's more about seeing how close numbers are to a 10.
Exactly. You're already thinking in terms of what the document calls by completion or non-completion or by the deficiency.
So like 59 plus 4, 59 is just 1 away from 60.
Right.
So it's the same as 60 plus 4 minus 1, which is 63.
Now you're getting it.
This circle is like a secret decoder ring for math. Is there even more to it?
There is. It also shows you groups of 3 numbers that add up to 10, like 1 plus 2 plus 7 equals 10. There are 8 combinations like that. You should try to find them all. It's a fun little challenge.
I might just do that. Now, this doubling and halving, that just sounds so practical.
Oh, it totally is.
Like something I could use every day.
Super useful. And easy. Basically, doubling means adding a number to itself, and halving is splitting it in 2.
Right.
Vedic math likes to break numbers into parts that are easier to work with in your head.
Like how the document breaks down 736 into 736.
Exactly. Then you double each part and add it up.
Oh, and I bet you could multiply and divide by 4 and 8 easily this way.
Absolutely. Just double or halve the number a few times.
Clever.
It all comes down to this idea of proportionately.
Proportionally.
It's using stuff you already know to make harder problems easier.
I like that a lot.
Yeah.
Okay, now this digit sums section. It's like math is about to get mystical.
It does feel kind of magical.
So what's a digit sum?
Basically, you add all the digits in a number together.
Okay.
And you keep doing that until you get a single digit number, less than 10.
Okay, so like for 57, it would be 5 plus 7, which is 12. Then 1 plus 2 is 3. I did it.
You got it. For bigger numbers, you just keep adding the digits together until you get that single digit.
Gotcha. But how does this actually help with, real math problems? It seems like a neat trick, but
Well, it's actually really useful for checking your work. Did you know that adding and multiplying preserves digit sums?
wait, so if I multiply two numbers together, the digit sum of the answer should be the same as the digit sums of those two original numbers.
Close. You need to multiply the digit sums of the original numbers and then reduce that to a single digit. Then it should match the digit sum of your answer.
That's so cool. Way faster than redoing the whole problem. Okay, this one is definitely going into my mental math toolbox. All from 9 and the last from 10. This sounds pretty intense.
It's all about subtracting from powers of 10.
Like 10, 100, 1,000, and so on.
Yep. It might sound confusing, but it's actually pretty intuitive once you get the hang of it.
Okay, let's try it. The document uses the example of 1,000 minus 276.
Perfect example. So instead of borrowing, which can be tough to do in your head, you subtract each digit of 276 from 9, except the last digit, which you subtract from 10.
So 9 minus 2 is 7, 9 minus 7 is 2, and 10 minus 6 is 4. So the answer is 724. That was so much quicker than the way I usually do.
I know, right? It's especially handy for money stuff. Like, imagine you buy something for $3.85 and give the cashier a $10 bill. You can instantly figure out your change using this. It's $6.15.
Wow, that's super useful. No more awkward fumbling with change at the register. So what other adventures await in this Vedic math world?
Well, next up, we can explore some special multiplication techniques. They're where Vedic math really shines, using all sorts of cool patterns to make multiplication super fast and efficient.
Ooh, I love patterns. Bring on the math magic.
You got it. Okay, so you ready for this? Multiplying by 11. Vedic math makes it super easy.
I feel like I should know this one. Don't you just like add a 0 at the end? Or, oh wait, no, that's 10.
Close. But with 11, you take each digit, add it to the digit on its right, and that becomes the new digit in the answer.
Okay, let me try that. So like 45 times 11, 4 plus 5 is 9, so the middle digit is 9, and the first and last digits are just the same as the original number. 495.
Whoa! You got it. It's like a little dance the digits do. And if the two digits add up to more than 9, like 10 or higher,
oh yeah,
you just carry the 1 over like you normally would with addition.
So for 57 times 11, 5 plus 7 is 12, so I write down the 2. Carry the 1, which makes the 5 a 6. 627. That is so much faster than the old way I learned it.
I know, right? It's cool.
Okay, more please.
Yeah.
What about those other special multiplication tricks? The document mentioned by one more than the one before, for when the numbers have the same first digit, and the last digits add up to 10.
Oh, yeah, that's a good one. Okay, let's try 32 times 38.
Okay, they both start with 3, and 2 and 8 make 10.
Exactly. So you multiply that first digit by 1 more than itself. So 3 times 4.
12.
Right, that's the first part of your answer. Then you multiply the last digits together. 2 times 8 is 16. So your answer is 1216.
Wow, that is so cool.
And you know what's really neat?
What?
Think about this.
Okay.
32 and 38, they're both the same distance away from 35.
Oh, yeah.
And if you square 35, it's 1225. So you can kind of see how 32 times 38 is a bit less than that.
Wait, so there's a connection between multiplication and squaring? This is blowing my mind.
I know, right? It's like all these different math concepts are like talking to each other.
I love it. Okay, so what about when the first digits add up to 10, but the last digits are the same, like 24 and 84?
Okay, well, there's this principle, the first by the first, the last by the last. It basically means you multiply the first digits and you multiply the last digits. So 2 times 8 is 16, and 4 times 4 is 16. Put them together and you get 2016.
So it's like that last one, but with the numbers reversed. I'm starting to notice how a lot of these Vedic math tricks build on each other,
You're getting it. And, there's actually another way to solve that one. Remember the vertically and crosswise method?
Oh, yeah.
We'll talk about that more later. But yeah, you could totally solve that one with that method too.
I can't wait. Okay, how about those numbers that always trip me up? 99, 999. Like, how do you deal with those?
Oh, Vedic math makes those super easy. Okay, let's say you're multiplying 32 by 99. First, you subtract 1 from 32, so you get 31.
Okay, I see where this is going.
That's the by 1 less than the one before part. Now we use that all from 9 and the last from 10 thingy. So you get 68, put it all together, 3168.
Wait, seriously? That's it?
Yep. Vedic Maths just breaks it down into a couple of simple steps, and this trick works for any number that's all 9s.
Amazing. Starting to feel like a math whiz. Okay, what else is there?
Well, believe it or not, we can actually use averages to multiply.
Averages. Okay, now you've really got me curious.
Let's say you want to multiply 31 by 29. Now, the average of those two numbers is 30.
Right.
So you square 30, which is 900, and then just subtract 1.
899. Whoa, how did that even work?
It's all about the relationship between the numbers, right? 31 is 1 more than the average, 29 is 1 less. So their product is just the average squared minus the difference squared, which is just 1. Oh, okay, I think I'm following. Barely. That is so cool.
I know, it's like seeing these hidden patterns, right?
Definitely. Okay, this is all amazing for these special cases, but what about, like, general multiplication and division? Does Vedic math help with those too?
It does. For multiplying two-digit numbers, there's a method called vertically and crosswise. It breaks down the problem into smaller steps, just like a lot of Vedic math techniques.
Ooh, I like the sound of that. Let's hear it.
Okay, let's try 24 times 43. This one's in the document. So first, you multiply the ones digits, 4 times 3, which is 12. Write down the 2 and carry over the 1.
Okay, feels like regular multiplication so far, but I bet it's about to get interesting.
Right. Now comes the crosswise part. You multiply the ones digit of the first number by the tens digit of the second number and vice versa. So 4 times 4 plus 2 times 3.
Okay, let's see. That's 16 plus 6, which is 22, plus the one I carried over, so 23. Now what?
Write down the 3, carry over the 2.
I'm seeing the pattern here. We're weaving the numbers together. Now, last step. Multiply the tens digits. 2 times 4, which is 8. Add that 2 that we carried over, you get 10. Write that down. The answer is 1032.
Whoa. That was smooth. Breaking it down like that makes it so much easier to do in my head.
Right. And the cool thing is you can actually use the same method for 3-digit numbers too. The document explains it.
Wow. So no matter how big the number, Vedic Math has a way to tackle it. This is amazing.
And there's more. For squaring, there's a super cool concept called duplexes. It's very elegant.
Duplex. Okay, you're speaking my language. I love a good math puzzle. What are duplexes?
It's basically a way to think about the products you get when you square a number. So like for a single-digit number, the duplex is just the square of that number. But for a two-digit number,
Yeah.
it's twice the product of its digits.
Okay, so the duplex of 5 is 25, and the duplex of, let's say, 26, it'll be 2 times 6, so 24.
Yep, exactly.
But how do I use them to square numbers?
Okay, let's try squaring 34. The duplex of 3 is 9. The duplex of 34 is 2 times 3 times 4, which is 24, and the duplex of 4 is 16. You just add all those together and carry over any extra digits like regular addition. So 9 plus 24 plus 16 gives you 1156.
Wow, that's 34 squared.
See? It's like a secret code within the numbers.
Love it. What about bigger numbers?
For larger numbers, you can combine this duplex trick with something called number splitting. Makes it even easier.
Vedic Math always has a trick up its sleeve.
Yeah.
Okay, what about division?
Vedic Math has you covered there too. There's a general method that uses something called flags, which are based on the divisor.
Flags. Okay, you're definitely keeping me on my toes here. What are flags?
Well, let's look at 308 divided by 51. That's an example from the document. The flag in this case is 1 because it's the second digit of the divisor.
Oh, okay, so how does that help?
You start by asking, how many times does 5 go into 30? That's 6, with a remainder of 0. Now here's where the flag comes in. You multiply the flag, 1, by the quotient, 6. So you get 6. Subtract that from the next digit in the dividend. So 8 minus 6 is 2.
So the answer is 6 remainder 2. That seemed pretty easy.
Exactly. And you can use this for bigger numbers too. It breaks down the problem into those smaller, simpler steps.
This is way less scary than that long division stuff I learned in school.
Right.
So much easier. And what if you don't want a remainder?
Oh, there's a trick for that too. You can decimalize the remainder.
Decimalize. Sounds a little complicated.
No, it's actually pretty simple. You basically just keep dividing, but instead of adding a 0 to the dividend, you multiply the remainder by 10.
Oh, so you can get a decimal answer instead of stopping at a whole number with a remainder.
Yep, exactly. It's like another tool in your Vedic Math toolbox.
This is so awesome. I can see how Vedic Math can help with, like, all kinds of calculations. It's so much more flexible.
Exactly. And guess what? We haven't even talked about bar numbers yet.
Bar numbers. Wait, there's even more. My brain is going to explode, but like in a good way. So what are bar numbers?
They're a really cool concept. Basically, it's a different way of writing numbers. Might sound confusing at first, but it can actually make some calculations easier, especially subtraction.
Okay, you've got my attention. Tell me more about these bar numbers.
Remember how the document mentioned telling time?
Yeah, like how 5.45 is 45 minutes past 5 or 15 minutes before 6.
Exactly. It's kind of like that. A bar number represents a number as the difference between a base number and a smaller number. So take 29. It's close to 30, right? So you could write it as 31 with a bar over the 1. That means 30 minus 1.
Okay, so 52 would be like 52 with a bar over the 2, meaning 50 minus 2. And 412 would be 412 with a bar over the 1 and the 2, which is 400 minus 10 plus 2. But isn't that just 392?
You're right, they represent the same value, but bar numbers are super useful for making subtraction easier.
Okay, give me an example.
Okay, try 435 minus 276. Usually you'd have to subtract each column and borrow when needed. But with bar numbers, you just subtract each column individually.
Okay, so 4 minus 2 is 2, 3 minus 7 is negative 4, and 5 minus 6 is negative 1. What do I do with the negative numbers?
You turn them into bar numbers. Negative 4 becomes 6 with a bar over it because 10 minus 4 is 6. And negative 1 becomes 9 with a bar over it. Now you've got 269 with bars over the 6 and 9.
Right, that's not right, is it?
Almost. Remember, the 6 with the bar means 60. So 269 with bars over the 6 and 9 is like saying 200 minus 60 plus 9, which is 149.
I see. It's like a whole different way of grouping the numbers. I can see how that could be useful.
Exactly. And the cool thing is you can use bar numbers for addition, multiplication, and division, too. It's a whole new way of thinking about numbers.
This is amazing. It's like learning a new language for math.
Right. And that's what's so cool about Vedic math. It's not about throwing out the old ways, but about having all these different tools and approaches. It's all about flexibility.
I totally agree. Vedic math is helping me see all these cool connections and patterns in numbers.
It's so cool, right? It makes math more intuitive and fun.
Definitely. Okay, before we move on, is there anything else that you think our listeners should know about Vedic math? Any big takeaways?
Well, there's so much more to explore in Vedic math. It's not just about arithmetic. There are techniques for algebra, trigonometry, and even calculus. But I think the most important thing to remember is that Vedic math is not just about speed or tricks. It's about understanding the beauty and the connections in math.
I love that. It's like it's helping us appreciate math as an art form, not just a bunch of rules and formulas.
Exactly. It's about seeing the elegance of math. It's about understanding the patterns of the universe.
Yeah, it's like opening up a whole new dimension of understanding.
Right.
When I first started looking at all this stuff,
Yeah.
I have to admit I was kind of intimidated. It seemed like, whoa, a lot to take in.
It can be a little overwhelming at first.
But now I'm actually excited to learn more.
That's great. That's the spirit. Curiosity and playfulness, not fear.
I'm already thinking of how I can use some of these techniques in everyday life, like no more struggling with tips at a restaurant or making
Yeah.
sure I got the right change at the store.
I know, right?
Super practical.
Totally. And you never know, maybe it will even help you see patterns in other parts of your life.
Oh, that'd be cool.
Yeah.
Okay, so before we wrap
Yeah,
up, I've
no.
got to ask, what's one Vedic math technique that really blew your mind? Or one that you use all the time?
Ooh, that's a tough one. They're all so cool. You know what? I think I'd have to go with the vertically and crosswise method for multiplication.
Oh, that one's definitely a favorite of mine too.
It's just so versatile, no matter how big the numbers get, it always works.
And it's so efficient.
Oh,
It makes multiplication feel almost easy.
exactly. It turns what could be a real chore into this, fun little puzzle.
Well, this has been an amazing deep dive. I feel like I've learned so much.
It's been a pleasure exploring with you. I love how enthusiastic you are about Vedic math.
Can't help it. It's just so fascinating. And a big thanks to our listener for suggesting this topic.
Yes, thank you. We always love getting suggestions from our listeners. So if there's anything else you'd like us to deep dive into, let us know.
We're always up for adventure. So until next time, keep those minds curious, everyone.
And keep exploring. See you on the next deep dive.
Let's go for the practice mode to summarize what we have learned so far. Here are some practical examples of the tricks listed in the sources, explained in easy-to-understand, step-by-step processes. Completing the whole. Using subtraction to simplify addition. This trick involves viewing a number as how close it is to the next multiple of 10 and adjusting the sum accordingly. For example, to calculate 38 plus 24, note that 38 is 2 less than 40. Therefore, 38 plus 24 is the same as 40 plus 24, 2. Calculate 40 plus 24 is equal to 64. Finally, subtract 2 to get the answer. 64 minus 2 is equal to 62. Simplifying addition by groups of 10. This technique utilizes number pairs that add up to 10 to simplify addition. For example, to add the numbers in the list 7 plus 6 plus 3 plus 4, find pairs that make multiples of 10. Notice that 7 plus 3 is equal to 10, and 6 plus 4 is equal to 10. Therefore, the sum is simply 10 plus 10 is equal to 20. Subtracting near a base. This method simplifies subtraction when dealing with a number close to a multiple of 10. For example, to calculate 53 to 29, observe that 29 is 1 less than 30. So, 53 to 29 is equivalent to 53 to 30 plus 1. Calculate 53 minus 30 is equal to 23. Finally, add 1 to get the answer. 23 plus 1 is equal to 24. Doubling and halving. Mentally multiplying and dividing by 4 and 8. This technique uses doubling or halving multiple times to multiply or divide by 4 or 8. For instance, to multiply 35 by 4, double 35 twice. 35 times 2 is equal to 70, and 70 times 2 is equal to 140. Therefore, 35 times 4 is equal to 140. Similarly, to divide 72/4, have 72 twice. 72 divided by 2 is equal to 36, and 36 divided by 2 is equal to 18. Therefore, 72 divided by 4 is equal to 18. Mentally multiplying and dividing by 5, 50, and 25. This method leverages multiplying or dividing by 10 or 100, which are easier to calculate. For example, to multiply 26 by 5, multiply 26 by 10, and then have the result. 26 times 10 is equal to 260, and 260 divided by 2 is equal to 130. Therefore, 26 times 5 is equal to 130. To divide 320/5, double 320, and then divide by 10. 320 times 2 is equal to 640, and 640 divided by 10 is equal to 64. Therefore, 320 divided by 5 is equal to 64. Digit sums. Casting out nines. This trick simplifies finding the digit sum of a number. For example, to find the digit sum of 94,993, simply cast out the nines. The remaining digits are 4 and 3, so the digit sum is 4 plus 3 is equal to 7. Checking with digit sums. Digit sums can be used to check the accuracy of addition and multiplication. For instance, in the addition problem 34 plus 52 is equal to 86, the digit sums are 3 plus 4 is equal to 7 and 5 plus 2 is equal to 7. The sum of the digit sums is 7 plus 7 is equal to 14, which reduces to 1 plus 4 is equal to 5. The digit sum of the answer, 86, is 8 plus 6 is equal to 14, which also reduces to 1 plus 4 is equal to 5. Since the digit sums match, the addition is likely correct. All from 9 and the last from 10. Subtracting from a power of 10. This sutra simplifies subtracting a number from a power of 10, like 100, 1000, etc. For example, to calculate 1000 to 276, subtract each digit of 276 from 9, except for the last digit, which you subtract from 10. So, 9 to 2, 9 to 7, 10 to 6 results in 724. Therefore, 1000 minus 276 is equal to 724. Number splitting. Splitting numbers to simplify problems. This technique breaks down numbers into smaller, more manageable parts for easier mental calculation. For instance, to add 3,642 plus 2439, split the numbers into 36, 42, and 24, 39. This allows you to add 36 plus 24 is equal to 60 and 42 plus 39 is equal to 81 separately. Combining the results, you get 6081 or 6081. Base multiplication. Multiplying numbers just above or below 100. This method uses the difference between the numbers and 100 to simplify multiplication. For example, to multiply 98 by 88, note that 98 is 2 below 100 and 88 is 12 below 100. Subtract 12 from 98 or 2 from 88 to get 86. Multiply the differences. 2 times 12 is equal to 24. Combine the results to get the answer. 8624. Multiplying numbers near different bases. This technique applies the same principles to numbers near different bases. For instance, to multiply 94 by 9997, observe that 94 is 6 below 100 and 9,997 is 3 below 10,000. Subtract 6 from 9997 or 300 from 94 to get 9397. Multiply the differences. 3 times 6 is equal to 18. Combine the results. 939718. Bar numbers. Using bar numbers. Bar numbers represent numbers that are close to a base number. For example, 31 represents 30 to 1, which is 29. 52 represents 50 to 2, which is 48. Arithmetic of bar numbers. Bar numbers can be used in arithmetic operations like addition, subtraction, multiplication, and division. For instance, to add 29 plus 48, you can rewrite it as 31 plus 52. Adding the bar numbers gives 83, which translates to 80 to 3, or 77. Special multiplication. Multiplying by 11. This trick simplifies multiplying a number by 11. For example, to multiply 45 by 11, write down the digits of 45 with a space in between, 4, 5. Add the digits. 4 plus 5 is equal to 9, and place the sum in the space, 495. Therefore, 45 times 11 is equal to 495. General multiplication. Multiplying two-digit numbers. This method involves breaking down the multiplication into smaller steps. For example, to multiply 24 by 43, first multiply the unit's digits. 4 times 3 is equal to 12. Then, cross-multiply and add. 2 by 3 plus 4 by 4 equals 22. Finally, multiply the tens digits. 2 times 4 is equal to 8. Combine the results. 8 hundreds plus 22 tens plus 12 units equals 1032. Squaring. Squaring numbers ending in 5. This trick provides a quick way to square numbers ending in 5. For instance, to square 35, take the first digit 3 and multiply it by 1 more than itself. 3 times 4 is equal to 12. Append 25 to the result, 1225. Therefore, 35 superscript 2 equals 1225. General squaring using the duplex of a number. This method utilizes the duplex of a number to calculate its square. For example, to square 34, find the duplexes of 3, 34, and 4. The duplex of a single-digit number is its square. D3 equals 9. The duplex of a two-digit number is twice the product of its digits. D34 is equal to 2 times 3 times 4 equals 24. Combine the duplexes. 9, 24, 16. Adjusting for carries, you get 1156. Therefore, 34 superscript 2 equals 1156. Special division. Division by 9. This method provides a shortcut for dividing by 9. For instance, to divide 32/9, write the first digit of the dividend 3 as the first digit of the quotient. Add the digits of the dividend. 3 plus 2 is equal to 5. Write the sum, 5, as the next digit of the quotient, 35. Since the sum is less than 9, the remainder is the sum itself, 5. Therefore, 32 divided by 9 is equal to 3 remainder 5. General division. General division. This method uses a flag digit to simplify division. For example, to divide 308/51, take the second digit of the divisor, 1, as the flag digit. Divide the first digit of the dividend, 3, by the first digit of the divisor, 5. Since 5 doesn't go into 3, consider the first two digits, 30, and divide by 530/5 is equal to 6. Write 6 as the first digit of the quotient. Multiply the flag digit, 1, by the quotient digit, 6. 1 times 6 is equal to 6. Subtract the product from the next part of the dividend, 0.8. 6 is equal to 2. The remainder is 2, and the quotient is 6. Therefore, 308 divided by 51 is equal to 6 remainder 2. Thanks for your attention. These examples demonstrate the practical application of various Vedic math tricks, simplifying complex calculations through clever techniques and mental manipulation of numbers. Do not forget to keep listening to them at regular intervals to master them.